Hello viewers, Ragadaruna taking you through the story for A-Level Physics Paper 1. And this video I'm going to go through the topic of projectile motion. So this video is suitable for students in both Senior 5 and Senior 6 offering physics as part of their combination. So before we proceed, let's first look at the course outline of this paper. So Physics Paper 1 is divided into 3 parts. The first part is mechanics, where 4 questions come from these topics. The second part is heat, where 3 questions come from these topics. And the third part is modern physics, where 3 questions come from these topics. So what is ticked is already available on this platform, and what is not yet ticked means it is yet to be uploaded. But on this platform, you're interested in the calculations, so complete notes are available in these books. For example, Physics 1, Mastering A-Level Physics Paper 1 contains notes, worked examples, and trial questions of mechanics, heat, and modern physics. If you need a copy, contact the author on any of these 2 contacts. And a complete set has 3 books, that is Physics 1, then there's also Physics 2, and also a topical question bank. The same applies to Principal Mathematics. There is Math Paper 1, Math Paper 2, and the topical question bank. So for any of the copies, contact the author on any of these 2 contacts. So now we shall start our topic of projectile motion. So previously, in motion under a straight line, or motion in a straight line, we looked at what we call vertical motion under gravity, where a particle is projected vertically upwards. Okay, but in this case, the particle returns to the point of projection. But what if it is projected at an angle? So in that case, it will land somewhere away from the point of projection. So that is what we call projectile motion. And it is projection at an angle. So projectile motion, a projectile is a particle or body which, when given an initial velocity, can be left to move on its own in air in presence of a constant force field. And in such a motion, just like we considered under vertical motion under gravity, the effect of air resistance is neglected. Even in this topic, we shall neglect the effect of air resistance. So projectile motion is the motion of a body which, after being given an initial velocity, it moves under the influence of gravity. So you need to derive some of the formulas and also understand some of the terms which will be used in this topic. So with that, we shall consider a particle projected from level ground at point A with a velocity u at an angle. Remember, here we're interested in projection at an angle above the horizontal as shown below. So we shall need to make a sketch. So we need a ground, then that is the part at point A where the projection will be. So we shall give it a velocity of u at an angle of theta. And when that happens, the particle will follow this path. So in that, it will be a projection to move from A through B through C up to point D. So such a motion is what we are interested in. And I think in the previous video, that is video 003 of vectors and scalars, we looked at what we call resolving of vectors. So that video is that concept of resolving is also needed in this topic. So if you skipped that video, I encourage you to first watch that video of vectors. That is when you can easily understand this video of projectile motion. So there are 2 videos, one of motion in a straight line and also vectors and scalars. Those are the 2 videos which will be useful for you to understand this topic. So this velocity, it is at an angle, meaning it can be resolved into two components, horizontally and vertically. So this U.A.C.E is the horizontal component of this velocity, of the initial velocity, and U.Y. is the vertical component of the initial velocity. Then we have what we call Hmax, which stands for maximum height attained by the particle. Then we have another term called range. Range is the distance from starting point to the end point, as long as this line is, or as long as the particle started from the ground. Because sometimes it may be at a cliff, so their range is. So when it is at a cliff, as we shall see, range will be different because it moves up the ground, but our range has to be a horizontal through the starting point, and that will be the range. But we shall look at it more in details on this video. So at any point there is a velocity v. So this is v, velocity at any point. So let's consider point C when it is moving downwards. So that velocity is also still at an angle, and it can be resolved horizontally and vertically. So now I think realize we're resolving vertically and horizontally, meaning in projectile motion we break down the motion into two components. We consider vertical motion and also horizontal motion, after which you can combine to get this final velocity of the resultant velocity, as we have seen the calculations. Okay, now we shall go to the terms used. Some of them you have looked at them, but we shall still go through them. One is the angle of projection. So I think in the diagram you saw the value theta. That is what we call the angle of projection. So this is the angle that the direction in which the particle is projected makes with the horizontal. So we project at this direction, so the angle between that direction and the horizontal will be the angle of projection. Okay, then another term is called initial velocity components. So components like we saw in the video of vectors and scalars, it is got by resolving. So this one has two components. It has vertical component and horizontal component. So calculations of projectile motion require splitting the initial velocity into two components, that is U.X and U.Y. So U.X is the horizontal component, U.Y is the vertical component. So how is resolving done? We shall remind ourselves, though we already saw it under vectors and scalars. So what we do, this velocity here is divided into two components. One is the horizontal, another one vertical will move upwards. So in that case, it will form a right angle triangle, and we can use SOHCAHTOA. So cos will be adjacent over hypotenuse. Then sine will be opposite over hypotenuse. So from there I can make U.X the subject and also U.Y the subject. So this is what we saw under vectors and scalars. So I'm just reminding you that U.X, because the angle is lying on the horizontal component will have cos, and the vertical component will have sine. So always remember that U.Y has sine and U.X has cos. Okay. So that is initial velocity components. Another term we need is velocity at any time t. I think we saw that velocity at point C, that is called velocity at any time t. So horizontal component of velocity is always constant. This part is very vital. Horizontal component is always constant at any time. So U.X will be equal to Vx. And why is it so? It is because it is not affected by gravity. Remember, gravity is vertical. Therefore, the horizontal component is not affected by gravity. That is why it is constant. So Vx is equal to Ux and is equal to U cos theta. What about vertical component? For vertical component, we shall need the first equation of motion. V is equal to U plus AT. So this becomes Vy Uy minus Gt. But we know that Uy is U sine theta. So I can substitute to get Vy being equal to U sine theta minus Gt. So when I have Vx and I have Vy, I can use Pythagoras theory to come up with the final velocity they want at any time t. So horizontal is to the right and vertical is downwards. I think you remember in that diagram the velocity at point C. Therefore, complete the right angle triangle to come up with the velocity at any time t. And this beta is the direction. So that means that by Pythagoras theory, I can get the value of V, and also by SOHCAHTOA, I can get the value of beta. Then the other term is maximum height. I think you remember what we denoted as Hmax. That is what they call maximum height. So this is the vertical distance between the highest point reached by the projectile and the horizontal plane through the point of projection. So at maximum height, the vertical component of velocity is 0. So this is the condition for maximum height. At that point, vertical component, note that it is only vertical component, which is 0. Therefore, from the third equation of motion, we shall say Vy is equal to Uy, which is U sine theta squared minus 2gs. So when I substitute for vertical component being equal to 0, then S will be Hmax. My work is to make Hmax the subject. So make it the subject to come up with U squared sine squared theta over 2g. So that will be the formula for maximum height in case it is asked. The another term is called time taken to reach maximum height. So all these terms can be asked in the question that can tell you to calculate the maximum height or calculate the time taken to reach maximum height. Or that can tell you to calculate the velocity and time t, as we shall see in the calculations. So like I told you, I'm still reminding you that this video, in this platform, the notes we give are shallow. They are only intended to help us understand the calculations. So for you to have complete notes, I encourage you to buy the books I recommend. And they should be strictly the ones I recommend. So at maximum height, vertical component is 0. We already know that, so we can use first equation of motion. Vy is equal to Uy minus Gt. Then I remember that Vy is 0, so come and substitute 0 and then make t the subject. So the time taken to reach maximum height is U sine theta over g. Then you have another term called time of flight. So this is the time taken by a particle to return to the same horizontal level as the point of projection. So if this is the horizontal, it was from here, it goes up to this point. The time taken to move from here through this path up to here is what we call the time of flight. Okay. So for time of flight, it implies that the vertical displacement is 0, because it reached vertically, it has no displacement. The displacement is only horizontal. That is why you say that the vertical displacement is 0 at time of flight. Now, using the second equation of motion, we can come up with that. Remember, second equation is s is equal to ut minus a half gt squared. Now the s becomes the vertical displacement, which is y. Then the uy is u sine theta. But remember, it is ut, so it becomes this is uy, which is u sine theta, and this is the t. That's why ut sine theta comes from. Then this one is the same, minus a half gt squared. So at time of flight, this is 0. And capital T is what we call time of flight. So where there is small t, we shall put there capital T. To distinguish it from the time taken to reach maximum height. Remember, time taken to reach maximum height, we denoted it as t. Meaning that time of flight will be denoted as capital T to make them different. So when I make, here, my aim is to get capital T, so I'll factorize out capital T to come up with this. So either capital T is 0 or the whole of this bracket is equal to 0. So it cannot be 0, so we shall consider this to come up with the value of capital T as 2u sine theta over g. I think you realize the value, the time taken to reach maximum height was u sine theta over g. And the time of flight is twice the time taken to reach maximum height. So in case you've forgotten, you can remember the time taken to reach maximum height and multiply it by 2 to get the time of flight. Another term is called range. We also saw that in the diagram. So what is range? Range is the vertical distance from the initial position of a projectile to its final position on the horizontal plane. Note this word, on the horizontal plane from the point of projection. So it has to be a horizontal plane. It moves up to here. So this is a horizontal plane, meaning the distance from here up to here is what we call the range. Okay. So when you consider horizontal motion, remember horizontal motion is not affected by gravity, meaning acceleration has to be 0. So when you consider the second equation of motion, we shall come up with our range being equal to ut cos theta, and capital T is that. How does it come about? Because remember, second equation of motion is s equal to ut, okay, plus a half at. But remember, I've already said that the condition is that a is equal to 0, so the whole of this cancels. Okay, so remaining with this, the horizontal displacement is x, or we can call it r. In this time, it is r. Then this one, it is ux, so uxt. But ux, I think you remember that the horizontal component of initial velocity was u cos theta. So this ux will be replaced by u cos theta. Then this t will be replaced by the capital T because it is the time of flight. So that is where ut cos theta is coming from. Okay, then I remember that I know the time of flight. Come and substitute for time of flight. Then expand, this is 2u times u gives you u squared. That's why you see here 2u squared. Then sine theta cos theta divided by g. Okay, now this one is going to confuse you, but with time you will understand it. That is when you've covered trigonometry in math paper 1. But if you don't do math, then this formula is available in your math logbook. You can go and have a look at them because it will be used more frequently. You should remember that u sine theta cos theta is the same as sine to theta. It is an identity and is there in your math logbooks. So you can either consult from students who do math, or you get it from the logbook, but it's better you consult if you don't do math. So for now, we shall know that this is the same as this. But it is not a must that you should, in case you don't want to work with this, it is okay. You can quote this as the formula for range. Still, it will give the same answer. It will give the same answer. So for this case, I've chosen to use this, but in case you use this, it will still give the same answer, in case you are not contented with this expression. So sometimes they can ask for maximum range. So for maximum range, you have to remember that sine 2 theta is equal to 1. Therefore, come here and substitute for 1 here to come up with maximum range being equal to u squared over g. So if they just ask for range, this will be the formula, this or this. Then if they ask for maximum range, it should be u squared over g. Then another one is called the equation of trajectory. So equation of trajectory, first of all, what is a trajectory? A trajectory is the path described by a projectile. So in this case, when we drew this diagram, this path is what we call a trajectory. So when you come up, so this word equation of trajectory, we were looking for an equation which can give us this path. So we shall try first redraw the diagram to help us derive that equation. So that is the initial velocity at an angle theta, and the path will be that. So this path is what we call the trajectory. So to get an equation, we shall consider a variable point xy, where the displacement horizontal is x and vertical is y, to give you this point xy. Then this is the range from A to B. But our interest is this point xy. So for horizontal motion, remember acceleration is 0, therefore using the second equation of motion, x will be equal to ut cos theta. I think you remember that. When I make t the subject, I'll come up with x over u cos theta. Then considering vertical motion, we shall come up with you're still using the second equation of motion. Y is equal to ut sine theta minus a half gt squared. Therefore, substitute for t here and here to come up with this. Then simplify this and this cancels. Then sine theta over cos theta gives you tan theta. Okay. Then here, this square works on all these ones. So this is x squared. Here it will be u squared and cos squared. So these are that is what we call the equation of trajectory. You can use any. You can either use this, or you use this, or you use this. So all these equations are the same. Like I said, these are trigonometrical identities. You can consult from students of math, or you get them from your math logbook, because they are. So how does it come about? So here we need to remember that 1 over cos theta is equal to sec theta. Okay. That is why here it was 1 over cos squared theta. That's why here there is sec squared theta. Then this is also an identity. Sec squared theta is equal to 1 plus tan squared theta. So any of the three equations will give you the answer you want. So now that you have looked at the definitions and the formulae which are needed in this topic, we shall go through a number of questions. So these questions have been categorized into 3 parts. And the first part will be questions involving projection from level ground at an angle. So question 1 in this category came from U.A.C.E of 2010, paper 1, question 1D, and it says, calculate the range of a projectile which is fired at an angle of 45 degrees to the horizontal with a speed of 20 meters per second. So in this case, what we need to know is to remember the formula for range. Range is u squared sine 2 theta over g. After that, we shall substitute for u, for theta, and for g. Then when you use a calculator, the whole of this will give you this as the range they wanted. Then question 2 says, a gun is set to hit a target which has a maximum range of 25 kilometers. Find the velocity of the bullet. So you shall need the formula for maximum range. So we shall first convert this to meters, which gives you 25,000 meters. Then range is given by that, and after that we shall remember that for maximum, the sine 2 theta must be equal to 1. So when I substitute 1, I'll come up with formula for maximum range being equal to u squared over g. So the good thing, I know the maximum range, so I'll come and substitute for maximum range and for g, which is a constant, and remain with u as the only unknown. So next is to look for a way of making it the subject, and that will be the value of the velocity they wanted. Question 3 came from U.A.C.E of 2009, paper 1, question 1D, and says, a stone projected at an angle of 20 degrees to the horizontal just clears a wall which is 10 meters high and 30 meters from the point of projection. Find Roman 1, the speed of projection, and Roman 2, the angle which the stone makes with the horizontal as it clears the wall. So here I shall need to make a sketch to illustrate that. So this will be the wall, which is 10 meters high and 30 meters from the point of projection. So point O is the point of projection. And they told us the speed is unknown, but the angle at least is known. So you come and put the speed and the angle, then we project. So that is what the word just clears means. It means it brushes the top of the wall and then proceeds. So the horizontal distance is 30 and vertical is 10. Therefore, I can use now the equation of trajectory. So remember, the equation of trajectory eliminates the time. So since they didn't talk about time in any of the two Romans, then you can use the equation of trajectory. So y is equal to x tan theta minus gx squared in brackets 1 plus tan squared theta over 2u squared. So you need to remember this formula. After that, you can now substitute. Our y is this. Our x is this. Okay, you can get from here. Y is this, x is that. Then the angle is 20 degrees. So we put it here and also here. Then x is already here, and g is a constant. So in that, I only have u as the only unknown. So I'll simplify. What I've done, I've taken the whole of this. Remember, the whole of this, there's a negative here. So I'll take this side to become positive, which gives you this, and take this 10 this side to become 30 minus 30 times 20 minus 10 to give you this. Then I will make you the subject, and that will be the velocity they wanted. So speed means they only want magnitude. So that is Roman 1. Roman 2, they want the angle which the stone makes with the horizontal as it clears the wall. So the angle at this point, remember here, the velocity is in this direction. So I need the angle to the horizontal. That means we need to get Vx and Vy. But before that, we need to get the time. So horizontal motion, horizontal distance is equal to ut cos theta. I think you remember that formula. Then you shall substitute x is that, u we have got, theta we know, and t is what we want to get. So t will now be equal to 0.4329. And now that we have t, it means we can get y. We can get Vy, because Vx is already a constant, but Vy changes with time. Therefore, Vy is u sine theta minus gt. I think remember this formula. Then you shall substitute for u, for theta, for g, and for t. Then you come up with this as the vertical component of velocity at the point of just clearing the wall. Then Vx is a constant is equal to Ux, which is u cos theta. I think you also remember that. Therefore, come and substitute for u and for theta to come up with this as the value. Now, both are positive. Then you shall remember this in vectors. I think you remember the sign convention in vectors. That positive horizontal is to the right. So you come and draw to the right, which is this. Then positive vertical is upward. So you come and draw where it stops, you draw an upward component. Then a line joining from start to the end is our velocity which they want. Okay, so this means that it was at by the time, okay, let's go back to the diagram. It means that this wall was somewhere here when it was still moving in an upward direction, like that. But because this is a sketch, you don't need to change after realizing it. You just leave it as it is, because it is a sketch. So you just leave it as it is and we continue. So what my aim is to get this value of beta. So tan, using SOHCAHTOA, tan beta will be equal to opposite over adjacent to give you this as the angle they wanted. That was question 3. Now shall go to question 4, which came from UNEB of March 1998, paper 1, question 1c, and it says a ball is kicked from a spot 30 meters from the goalposts with velocity of 20 meters per second at 30 degrees to the horizontal. The ball just clears the horizontal bar of the goalposts, just clears. Find Roman 1, the height of the goalposts, Roman 2, the time of flight, and Roman 3, how far behind the goalposts the ball lands. So shall need to make a sketch. So we have this velocity, and we have this angle, and we have the goalposts whose height we don't know, so let it be y. But we know that it is 30 meters from the point of projection, which is this. So I put our velocity there, 20 meters per second, and the angle is 30 degrees. Then we can project our ball. So this is what they mean by just clearing. So when it reaches here, it just clears and then goes until it lands at point B. Now the height of the goalpost is this value of y. Then the time of flight is the time taken to move from A through P up to point B. Then how far behind the goalpost the ball lands is this distance AB. So let's start with Roman 1 at point P using the equation of trajectory. Like I told you, you can use any of the three. Remember, there were three forms of the equation of trajectory. The one which is easier for you is what you use. So in the previous question, you used the one which has 1 plus tan squared theta. Now we are using the one which has cos theta. Any is okay. So that means that even if you used this one in question 3, you'll get the same answer. So I'll come and substitute for, I don't know the value of y, it is what I'm looking for, but x, I know it. So substitute for x, substitute for theta, which is here. G is a constant, x, I know it, then theta, I know it, and u, I know it. Meaning I can get the value of y, and that will be the height of the goal posts. Then next they want the time of flight. So there you shall need to remember the formula for time of flight. Then we can substitute. So time of flight, remember you said it is twice the time taken to reach maximum height. That's why there is this 2. So there is 2, then u, theta, and g to come up with this as the time of flight. Then part Roman 3, they want the extra distance, but before that we need to get the range. So let's just go back. We know this distance from here up to here. That means that if I get the range, which is from here to here, I can subtract 30 from the range to get the required distance. So I'll come and get the range. I can use this formula ut cos theta to substitute for u, for t, which is time of flight, and the angle to come up with this. That means that the extra distance will be got by subtracting. That is one way. You can also use the formula for range, which we derived, of u squared sine 2 theta over g. Substitute for u, substitute for theta, and for g to come up with this. It is slightly different, but both will be marked. So whatever you use, it is okay. Therefore, the extra distance in this case will become this. So any of these two is okay. That was question 4. Now we shall go to question 5. It says, a particle is projected from a point A with an initial velocity of 60 meters per second at an angle 30 degrees to the horizontal. At the same time, a second particle is projected in opposite direction. No, this word opposite. With initial speed of 50 meters per second from the point level with A, so it is on a straight line, and 100 meters from A. Okay. If the two particles collide, find Roman 1 the angle of projection, and Roman 2 when the collision occurs. So there still shall need to make a sketch. So you have those 2 points, point A and point B, and the distance apart is 100. So that's what they give us. So one will be projected in that direction, 60 degrees, and the angle is 30. Then the other one will be in the opposite direction, so it will be that, which is 50 degrees, and the direction we don't know it, and that's what they want us to get in Roman 1. So when you project, they will collide. So we shall project them. They said we shall project them at the same time. This is what it means here. At the same time. So at the same time, they are all projected, and they will collide at this point. Okay. At that point, that means that they have the same height from the ground, which is y. And 2, they have taken the same time to reach that point. But then 3, this distance moved by particle A and this one moved by particle B, when I add the 2, I must get 100. When that is in our minds, then we can proceed. So considering vertical motion for particle A, y is equal to, remember, ut sine theta. So u is this, angle is that, minus half gt. So g is 9.81. When I simplify, I'll come up with equation 1. Then considering vertical motion for particle B, still ut sine theta minus half gt. So u is that, theta we don't know it, and g is 9.81. So simplify to get the equation 2. So these two are the same, all are y. So we shall equate the 2 to come up with that. So simplify or collect like terms, realize that this and this cancels. So remain with that. Then t will also still cancel to remain with only theta. And therefore the value of theta can be got. And that will be the angle of projection they wanted. Then Roman 2, They want when the collision occurs, that is time. So considering horizontal motion, x1 plus x2 is equal to 100. But I know that x1 is ut cos theta, which is ut cos 30. And x2 is also ut cos theta. So we got this as this. So here they should be to 2 decimal places because angles are 2 decimal places. Then I will simplify. What I've done, I've pulled out, factorized out t to come up with. So when I remove t, I'll remain with 6 cos that and 50 cos this, like that. Then I make t the subject, and when I make it the subject, I'll come up with that as the time they wanted. That was the first category of questions. The second category will be questions involving projection from the top of a cliff at an angle. And the first question will be from U.A.C.E of 1995, paper 1, question 1b. And it says, a bullet is fired from a gun placed at a height of 200 meters with a velocity of 150 meters per second at an angle of 30 degrees to the horizontal. Find Roman 1, the maximum height attained, and Roman 2, the time taken for the bullet to hit the ground. So here we still need a sketch. We have a height of 200 meters. Okay. Then you have a projection of this velocity and that angle. So I shall put it there. 150 and the angle is 30. Then now we shall project the bullet and it will hit the ground at this point. So I think you realize that here the coordinates are x negative 200 because this point is 200 meters below the point of projection. So any distance below the point of projection is negative. Okay, so that is h max, maximum height from the point of projection, and this will be the total horizontal distance traveled. It is different from range. Range is the distance from here up to here, but this is the total horizontal distance traveled. Therefore h max is given by, this is the formula, u squared sine squared theta over 2g. So you use there, theta is there, and g is there. That means that h max will be that. But they didn't say maximum height from the point of projection. They just said maximum height. So we shall measure it from the reference point, which is the ground. And therefore maximum height will be got by saying 200 plus h max to give you that as the maximum height. That was Roman 1. Roman 2, time taken, we shall consider vertical motion, which gives that formula. Then we substitute. I think rather now we are using negative because the final point is below the point of projection. So negative 200. So if you forget the negative, then everything is not okay. Then u is there, theta is there, g is there. So t is the only unknown. Therefore, I'll have a quadratic in t and solve it using either bulldozer or factorization method. But in this topic, it is bulldozer which is recommended because the values of t sometimes will be in decimal places, meaning you cannot factorize. For example, in this case, I think I can see they're in decimal places, meaning using the method of factorization was not okay. It will not give you the answer. So there are two values of t, but one, the negative one, is not needed. So that t cannot be negative in this case. Therefore, t is 17.6064 seconds. That was question 1. Question 2 says, a boy standing at the edge of a vertical cliff 40 meters high throws a stone to the sea at an angle of 30 degrees, okay, to the horizontal, and the speed of projection of the stone is 20 meters per second. Find Roman 1, the time of flight of the stone. Roman 2, the range covered by the stone. Roman 3, how long the stone is in air. And Roman 4, how far the stone hits the sea from the base of the cliff. And Roman 4, the velocity of the stone just before it hits the water in the sea. Okay, so we shall do it slowly. So let us start from Roman 1. But first of all, we shall need an illustration. So this OP is now our cliff. They say it is 40 meters high. And the velocity was 20 meters and the angle was 30. Now we shall project using that velocity to come, and the particle will land at this point. So I think you realize still we have a negative because this point is 400 meters below the point of projection. So that is our H max, and this is our total horizontal distance. Remember, it is not the range. So Roman 1, they want a time of flight. We shall quote the formula 2u sine theta over g. Substitute for u, theta, and g to come up with a time of flight as that. Then Roman 2, they want the range covered by the stone. So range, so we shall quote the formula. That range is ut cos theta. Still, we can use the previous formula we used of u squared sine 2 theta over g, but now here I've chosen to use this, since I already know the time of flight. So time of flight and theta and u to come up with the range which they wanted. So this range is the distance from here up to here, horizontal distance through the point of projection. Then Roman 3, they want how long the stone is in air. That is the total time taken. It is different from time of flight. Time of flight is the time taken to cover a range, but total time taken is the time taken to move from here, from P through Q up to R. That's the time they want. So using second equation of motion, y is equal to ut sine theta minus a half gt squared. So substitute y is negative 40. Okay, then u is 20, theta is 30, g is a constant. So I only have t as an unknown, which gives me a quadratic. And I have to solve it and get two values of t. So the negative will be eliminated to remain with only the positive. And that will be the time taken, or the total time spent in air. That is Roman 3. Roman 4, how far the stone hits the sea from the base of the cliff. So in that case, they want this value of x. So we are considering horizontal motion. We already know the total time spent in air, so substitute for total time, for initial velocity, and also the direction to give you this as the value of x. Then Roman 5, the velocity of the stone just before it hits the water in the sea. So Vx is the constant, is u cos theta, which gives that. Then Vy changes with time, so it is u sine theta minus gt. So u, theta, g, and t to give you, now this time it is a negative. Then from there we shall remember the sign convention. Positive horizontal, it is to the right. Okay, which is this. The negative vertical is downwards, which is this. I think you realize that we're not putting a negative here because the negative was to show us that it's going downwards. Then a line from start to end is our velocity which they want. velocity with which the stone hits the ground. So using Pythagoras theory, I can get the magnitude of that velocity. Then using SOHCAHTOA, I can get the direction. Then I can conclude. And that's what they wanted. Question 3 says a particle is projected with a speed of 36 meters per second at an angle of 40 degrees to the horizontal from a point 0.5 meters above the ground. It just clears a wall which is 70 meters on the horizontal plane from the point of projection. Find Roman 1, the time taken for the particle to reach the wall. Roman 2, the height of the wall. And Roman 3, the maximum height reached by the particle from the point of projection. So yes, we shall need a diagram. So we have this projected from a point which is 0.5 meters high, and the wall is here. We don't know the height of the wall, so this extra height distance will be, we shall call it y. But we know that the wall is 70 meters from the point of projection. And we know the velocity. The velocity was 36 and the direction was 40. So when you project using those parameters, you'll come up with this. Okay. Then with that diagram, we can start answering the questions. So Roman 1. Roman 1, they want the time taken for the particle to reach the wall. This from here to here. The good thing, we know the horizontal distance, which is x. That is what we shall use. So t is equal to x over u cos theta. Therefore, substitute for x, for u, and for theta to come up with this as the time taken. Then Roman 2, they want the height of the wall. Height of the wall, we already know 0.5, but we need to get the value of y. The good thing, we know the value of x. X is 70, y is what we need. So using the second equation of motion, y is ut sine theta minus a half gt. U, t, theta, and g t squared to give you this as the value of y. Therefore, the height of the wall will be got by adding this value of y to 0.5 to give you this. Then Roman 3, they want the maximum height reached by the particle from the point of projection. So there they are specified, point of projection. So we shall only get h max. H max is given by that u sine theta in bracket squared over 2g. So substitute for u, for theta, and for g to come up with this as the maximum height from the point of projection. So that has been the second category. Now the last category are questions involving horizontal projection from the top of a cliff. So the previous two, the first and second category, involved questions where projection was at an angle. But what if the projection is entirely horizontal? How do you deal with such questions? So this is the category we are going to look at. And the first question came from UNEB of 2006, paper 1, question 1b, and it says, a projectile is fired horizontally from the top of a cliff 250 meters high. The projectile lands 1.414 exponent 3 meters from the bottom of the cliff. Okay, find Roman 1, the initial speed of the projectile, and Roman 2, the velocity of the projectile just before it hits the ground. So yes, we shall still need a sketch. So this will be our cliff, and they said the height is 250 meters. Then here they said the projection is horizontal, so shall put a horizontal velocity. We don't know the value, so shall just put u. Then when we project it using those parameters, this is what will happen. Okay, I think realize that immediately that the particle is projected, the motion is downward. It previously at an angle, it first moved up, then it would go down. But now it immediately starts going downwards, meaning that you shall remember the formula for downward motion, where A is equal to positive G. So previously we have been using A equal to negative G because it first moved up, then moved down. But now we shall use A equal to positive G because it immediately starts moving downward. Then 2, this velocity is entirely horizontal. I think you remember the previous video of vectors and scalars. When a vector is entirely horizontal, it implies that its vertical component is 0. So even here, the velocity is entirely horizontal, meaning the vertical component of velocity is 0. So considering vertical motion, here the vertical component will be 0. And you're putting plus because downward motion acceleration is positive g. Then you shall substitute for y, then for g, and be able to get the value of t. And that's what they wanted. So that is the value of t. We need the initial speed. So initial speed, you shall consider the horizontal motion. So this was vertical motion, we have used it to get time. Then for horizontal motion, x will be equal to ut. Then substitute for x and for t to get the value of u. And that will be the value of u. That was Roman 1. Then Roman 2, the velocity of the projectile just before it hits the ground. So like we said, the horizontal component is constant, but the vertical one changes with time. So Vx is equal to u. But Vy changes with time, so we shall use the first equation of motion to come up with 0, because 0 vertical component initially is 0 because the motion was entirely horizontal. So it is 0 plus gt, so substitute for g and for t to get the value of Vy. Okay, now here, remember from sign convention, we could take positive velocity, positive vector to be upward. But when it comes to horizontal projectile, it is a little unique because the motion is entirely downward, meaning that the vertical sign will mean downward motion. So that's the special case for horizontal projection. It's a bit alters the rule for sign convention. So we shall come and draw our positive horizontal, which is to the right, and now the positive vertical is downward. It has somehow altered the rule for sign convention. So horizontal projection, the rules is somehow altered. Then we join from start to end. So I can use Pythagoras theory to get the value of V, and also use SOHCAHTOA to get the value, to get the direction. And that's what they wanted. Question 2 says a particle is projected horizontally at 36 meters per second from a point 1 to 2.5 meter above the horizontal surface. Find Roman 1 the time taken by the particle to reach the surface and the horizontal distance traveled in that time. Okay. Roman 2, the magnitude and direction of the speed, of the velocity of the particle just before it hits the surface. So this is somehow similar to question 1, the working, but I shall do it for you to get conversant with the topic. So the procedure will still be the same. We shall make a sketch, put the height, then put the velocity. This time the velocity is given. Then project using those parameters. So this will now be x. They say time taken for the particle to reach the surface and the horizontal distance traveled. Horizontal distance traveled is that. So yeah, first start by vertical motion, y will be equal to 1/2 gt squared. Then substitute for y, then for g, and make t the subject. So that is the time taken. Then for x, we shall consider horizontal motion. X is equal to ut, u is there, t is there, to come up with this as the value of x. Then Roman 2, they want magnitude and direction of the velocity of the particle. So we know the initial velocity, that will be the vx. Then for vy, it changes with time, so we shall get it using the equation. So g t to give you this. So now I shall draw our right angle triangle. Positive horizontal is to the right. Then vy, because we are under horizontal projection, it will be downward, though it is positive. Then from start to end, that will be our resultant. So you can use Pythagoras theory to get the value of v, and also use SOHCAHTOA to get the value of beta. And that's what they wanted. Then question 3 came from UNEB of 2014, paper 1, question 1a, and says, a bomb is dropped from an aeroplane when it is directly above a target at a height of 1402.5 meters. The plane is moving horizontally with a speed of 500 kilometers per hour. Determine whether the bomb will hit the target. So you put an aeroplane there and the horizontal ground here. They said at the height of this, so we shall put our height. Therefore, when it releases the bomb, it will move. It was initially moving. It was moving the direction. Therefore, the projectile will follow that horizontal projection and to land at this point. Remember, the target is here, but it lands at this point. Therefore, it will be off target by this distance. So let's get the value of x. First, vertical motion, y is equal to 1/2 gt squared. Then substitute for y, for g, and get the value of t. After getting the value of t, I can use now horizontal motion. First of all, this convert to meters per second to give you this. Then x is equal to ut, substitute for u and for t to get the value of this. And then you can conclude that the bomb won't hit the target. Why? Because it is off target by this distance. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on Newton's laws of motion and friction force. So if you have not yet subscribed, please click on the subscribe button below this video such that you can receive updates when the next video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp such that you can all benefit as a family.